Hello, everyone. Welcome. Sorry for being roughly 25 minutes. So let's get started. I'm going to start sharing my screen. And today we are going to talk about creating a lakehouse that we can get the necessary information from DP 700 exam documentation, right? I hope my screen is visible. And once again, let's get started properly. So, welcome to this video, and thanks for joining me on our Microsoft Fabric learning journey. In today's session, we are going to explore one of the most important building blocks in Fabric, the lakehouse, and you'll see how to create a lakehouse, upload and organize data, load it into Delta tables, run SQL queries, and even build a visual query to analyze your data. Whether you are just getting started with Fabric or expanding your data engineering skills, this walkthrough will give you a solid foundation for working with modern analytics in OneLake. So let's dive in and start building your first lakehouse. Okay, so I have to be sure that my everything is okay on my side. So I will take just only a couple of your seconds. So let me check once again. Okay, and yes, I hope, yeah, it works properly. So I can go on. Let me go back to my presentation. So organizations need to bring in, prepare, govern, and analyze data at scale. But doing this across disconnected tools and teams creates complexity and duplicated work. At the same time, this data must also be ready for AI scenarios like machine learning, co-pilots, and intelligent agents. Microsoft Fabric solves this by providing a fully integrated analytics platform built on OneLake. It brings all your data workflows into one environment where technical teams and business users can collaborate. Because data is ingested, prepared, and governed inside Fabric, the same trusted data used for reports and dashboards is instantly available for AI features, such as Copilot, data agents, and Fabric IQ. Your data foundation directly fuels your organization's AI efforts. In this video, we'll introduce Fabric, who is designed for and its core workloads, and how it supports both analytics and AI. So let's go on with our next slide. So scalable analytics often becomes complex, fragmented, and costly. Microsoft Fabric simplifies this by bringing all analytics tools into one unified, easy to use platform. Fabric is a SaaS, software as a service environment, where all data lives in one lake here. And it's stored in an open format. Every analytics engine can access one lake, giving you scalable, cost-efficient analytics from everywhere. One lake is Fabric's centralized data architecture. It removes the need to move or copy data between systems and unifies data across regions and clouds into one logical lake. It's built on Azure Data Lake software, Gen 2, and services, Gen 2, ADLS Gen 2, in other words. And OneLake supports Delta, Parquet, CSV, and JSON. All Fabric engines automatically store their data in OneLake, typically in Delta Parquet for tabular workloads. So every engine can work with the same data seamlessly. Code cards let you say reference data in one lake, or external sources like ADLS, Amazon, on-premises sources, so on and so forth. There is no copying. So without copying, it does it. And this keeps data consistent and always in sync with their source. Because all Fabric workloads write data into one lake using open formats, AI features like Copilot and data agents can use the same governed data as your reports and dashboards. The data you ingest, prepare, and govern in Fabric becomes immediately ready for AI workloads. Microsoft Fabric streamlines analytics development by bringing all tools into one SaaS platform, allowing every role to collaborate without repeating work. Data engineers can ingest, transform, and load data into one lake using pipeline. And we're talking about these data engineers, right? Pipelines for automation and scheduling. They store data in lakehouses using Delta Parquet and use notebooks for advanced transformations. Analytics engineers create high quality data in lakehouses and build semantic models in Power BI, creating a clean structure for self service analytics. Data science are using notebooks with Python and Spark to develop and test machine learning models. They work directly with Lakehouse data and can integrate with Azure machine learning to deploy models. And their predictions can also with Copilot and AI agents. Let's talk about data analysis. Data analysts can shape data with data flows and use direct lake to connect straight to one lake, reducing downstream preparation. They build interactive reports faster with Power BI. And we have low-code users, or in other words, decision makers, who can find trusted datasets in the one lake catalog. Use Power BI templates to build reports quickly. Perform simple extract transform low, in other words, ETL, with data flows, or ask questions in natural language through Copilot. Every role strengthens the organization's AI readiness. Clean, governed data from engineers powers Copilot and AI agents, while consistent semantic models from analytics engineers give AI the business context needed for accurate insights. This is Lakehouse that we can see on Fabric Platform. And Lakehouse in Fabric Platform blends the scalable storage of a data lake with the analytical power of a data warehouse. It uses Apache Spark and SQL engines to process data at scale, all built on top of one lake. A lakehouse gives you one unified place to store any type of data and still run fast warehouse-style analytics. Think of an organization using a traditional data warehouse. Structured data works fine, but semi-structured or and unstructured data from logs, IoT devices, or external feeds quickly becomes hard to manage. Multiple, multiple systems create silos and complex integrations. A lakehouse solves this by handling all data types in one platform while keeping strong analytical capabilities. And in this video, you will learn how lakehouses address these challenges. You'll see how to create a lakehouse, ingest and transform data, and query it using SQL and Spark. Actually, we are not going to use Spark, but we are going to use it query it with SQL. You'll also explore how well-organized lakehouse data powers downstream analytics and AI experiences across Microsoft Fabric. Traditional analytics often forces a choice. Data lakes give flexibility and scale, but lack structure, while data warehouses deliver strong analytics but struggle with diverse data formats and become expensive to grow. And lakehouses solve this by bringing warehouse style capabilities directly into your data lake, removing the need for separate systems. Let's talk about a little bit lakehouse design. Lakehouse organizes data into two areas, tables and files. Tables folder area contains Delta Lake tables. These are structured, queryable data that supports SQL through the SQL Analytics endpoint. I'll show you while I'm going to demonstrating. Enforces schemas and ACID transactions, connects easily to Power BI, benefits from automatic optimization. But files folder area stores raw or semi-structured data in any format, such as CSV, JSON, Parquet, images, or documents. Files offer flexibility for exploration, can be used as a staging area before transformation. Don't enforce schema or support direct SQL queries. And this design lets you keep raw data for compliance or reprocessing while also maintaining optimized tables for analytics. You can process files with Spark Notes or Dataflows Gen 2, then load the refined results into tables for fast querying and reporting. At the core of every lakehouse are Delta Lake tables. Delta Lake is an open source storage layer that adds reliability and structure to data lakes. When you create a table in a lakehouse, it's stored in Delta format inside one lake. Delta tables offer key benefits. First is ACID transactions. These transactions to keep data consistent even with concurrent reads and writes. Schema enforcement is to prevent bad or mismatched data. Time travel, allowing you to query or restore previous versions. Efficient updates and deletes, unlike traditional lake files. So these are the benefits of just Delta Lake tables. A Delta table is made up of Parquet files plus a transaction log that records every change. And this design supports both batch and streaming workloads using the same trusted data. When you centralize data in a lakehouse, securing that data becomes essential. Fabric provides multiple layers of access control to keep your lakehouse protected. So, use workspace roles for collaborators who need broad access to everything in the workspace. For limited read-only access, such as for analysts or Power BI developers, use item-level querying. For more granular control, the SQL Analytics endpoint supports row-level and column-level security, letting you restrict exactly what users can see. If you organize tables into schemas, you can also apply schema-level permissions to manage access by business domain. Fabric lakehouses support governance features like sensitivity labels, and you can expand governance further by integrating Microsoft Purview with your Fabric tenant. The data you organize in a lakehouse supports far more than reports and dashboards. Well-structured lakehouse data becomes the foundation for intelligent experiences across Microsoft Fabric. Clear schemas, consistent naming, and descriptive columns make your tables easy for both analysts and AI tools to understand. Fabric IQ data agents can query lakehouse tables through the SQL endpoint, turning natural language questions into accurate SQL queries. The quality of those answers depends on how well your data is structured. Copilot in Fabric also relies on clean lakehouse data. Copilot in Power BI can build reports and answer business questions when it can reason over well-defined tables and relationships. The same lakehouse data feeds semantic models that enable natural language exploration across Microsoft 365. Your investment in organizing and naming lakehouse data pays off across the platform. Strong data engineering practices create a reusable foundation for analytics and AI-powered experiences. So, to get value from your lakehouse, you first need to bring data in and prepare it for analysis. Whether you are loading local files, connecting to cloud data, or building transformation pipelines, understanding ingestion and transformation is key. You start by creating a lakehouse and exploring the tools that help you load and shape your data. So, a lakehouse is created inside a Fabric workspace and includes two storage areas, plus a SQL Analytics endpoint. First is tables. Tables store Delta Lake tables, uh, structured, queryable data that supports SQL, enforces schemas, and guarantees a seed transaction. So you can query these tables through the SQL endpoint and analyze them in Power BI. The second one is files. Files store raw or semi-structured data in formats like CSV, JSON, and Parquet. Files don't enforce a schema and give you flexibility for exploration and staging before transformation. When you create a lakehouse, schemas are enabled automatically. A default DBO schema is created, and you can add more schemas to organize tables by business domain like sales, marketing, HR, and so on. Schema-enabled lakehouses also support schema-level permissions and cross-workspace queries using the four-part namespace. You can work with your lakehouse in two modes. First is Lakehouse Explorer. So it adds and interacts with tables, files, and folders. This mode allows you to manage your data, upload your files, create your tables, and make changes to your lakehouse. And you can also add reference lakehouses to the Explorer pane. So you can browse and manage tables across multiple lakehouses side by side. The second one is SQL Analytics Endpoint. So it queries data tables using T-SQL in read-only mode. And you can create views, functions, and apply SQL security, but you can't modify the underlying data. Getting data into your lakehouse is the first step in your ETL process. Fabric gives you several ways to load and prepare your data. Upload. It adds local files or folders directly through the Lakehouse Explorer. Loading to table turns CSV or Parquet files into Delta tables with a no-code option that can append or override data. Dataflow Gen 2 uses Power Query to import and transform data. Notebooks use Spark to ingest, transform, and load data programmatically. And data factory pipelines are moving data from external sources using the copy activity. Choose your loading pattern based on your needs. Load raw files into the files area for staging or load directly into tables when the data is already in a supported format. Shortcuts let you bring external data into your lakehouse without copying it. A shortcut simply points to data in another storage location and makes it appear as a folder inside your lakehouse. And shortcuts reduce unnecessary data movement. You can reference data from other OneLake items, different storage accounts, or even other cloud providers. OneLake handles permissions and uses your identity to authorize access, so you must already have rights to read the target data. You can also create schema shortcuts, which map an entire schema of delta tables from another lakehouse or ADLS Gen 2. All reference tables show up as local tables, making cross lakehouse integration seamless. Most data needs scraping before it's ready for tables. You might load raw files into the files area first, then transform and move them into tables. Fabric gives you the same tools for both ingestion and transformation. First one is notebooks. This is ideal for data engineers using PySpark, SQL, or Scala. And Copilot can generate transformation code from natural language and explain existing Spark scripts. The second one is Dataflow Gen 2. This is great for Power BI and Excel users using the familiar Power Query interface. And the third one is pipelines. This provides a visual way to orchestrate ETL with multiple activities running in sequence or in parallel. And these tools let you build flexible, repeatable transformation workflows that prepare your lakehouse data for analytics and AI. The SQL Analytics endpoint gives you read-only access to lakehouse tables using T-SQL. It's created automatically with every lakehouse and lets you explore, filter, aggregate, and join data without touching the underlying files, just like a traditional SQL database. Common uses include ad hoc queries, just to quickly answer business questions, business intelligence connections from Power BI, Excel, or Azure Data Studio, and data validation after transformations. So you can also create SQL views to store reusable logic, helpful for applying business rules, simplifying joins or exposing created data to report authors. For example, a view that joins sales and product tables and filters for active products. The endpoint supports row level and column level security, giving you fine-grained control over what each user can see when querying through SQL. Notebooks give you a flexible code-driven environment for querying and analyzing lakehouse data. You can use Spark SQL for familiar SQL style queries or PySpark for programmatic data manipulation. Notebooks are ideal for exploration, statistical analysis, and preparing data for machine learning. Spark SQL uses a SQL syntax inside a notebook cell, a query just lakehouse tables. So let me share one example. So like select from schema table. And this is great for quick SQL-based analysis. I'm just going to show you the code, how it's written. And PySpark use Python to work with data, and you can run SQL using Spark SQL or using data frame API with methods like df.select and df.filter, and best for complex transformations and integrating Python libraries. And you can choose the method that fits your workflow. Spark SQL for simple, familiar patterns, PySpark for deeper, more flexible analysis. So let me share this screen also. I was talking about this code and also this code. This is what I just wanted to share. Okay. So let's go with next slide. And Spark notebooks are ideal when you need flexible, code-driven analysis. Typical scenarios include exploratory data analysis, investigating patterns, outliers, and relationships in your data. Then complex transformations, applying business logic that's easier to express in code than SQL, and cross space queries, sorry, joining data across lakehouses using their four-part namespace. And Spark notebooks give you freedom to mix SQL-style queries with PySpark mode, making them perfect for deeper analysis and advanced data preparation. And a little bit about Power BI. This is another workload of Microsoft Fabric. And Power BI is the business intelligence layer in Fabric, a place where business users interact with data through reports and dashboards. And Power BI connects to Lakehouse data in two main ways. So it queries the SQL Analytics endpoint. Analysts here can connect directly to the SQL endpoint from Power BI, Excel, or Azure Data Studio to run ad hoc queries and explore data before building reports. The second way is creating a semantic model, and you can build a semantic model that references specific lakehouse tables. This model defines relationships, measures, and business logic that Power BI uses for reporting. When you build reports on a lakehouse semantic model, Power BI uses Direct Lake by default. Direct Lake reads data straight from Delta Lake Parquet files. No import, no duplication. This gives fast performance and ensures reports always reflect the latest lakehouse data. Semantic models also power intelligent experiences. Clear relationships and well-defined measures help Copilot in Power BI generate visuals and answer business questions by reasoning over your lakehouse data. In these exercises that I'm going to show you in upcoming seconds, you will through the core steps of working with a lakehouse in Fabric. First, creating a lakehouse. So set up a new lakehouse in your workspace, giving you access to the tables and files areas, plus the SQL Analytics endpoint. So we're going to upload files like adding raw data files such as CSV or Parquet into the files section of the lakehouse. And also we're going to load file data into tables, converting uploaded files into Delta Lake tables using load to table, creating structured queryable data. And also we are going to query lakehouse tables using SQL. And we're going to use the SQL Analytics endpoint to run the SQL queries for exploration, validation, and analysis. Last but not least, we're going to create a visual query, building a visual query to shape and analyze data using a drag and drop interface without writing code. And these steps give you hands-on experience with ingesting, structuring, and querying data in a Fabric Lakehouse. You need a Fabric trial license with the Fabric preview enabled in your tenant. Now it's lab time, demo time. So let me just share. Okay, sorry. Actually, it's not. Okay, so now let me open. Yeah, new tab. So here, first of all, I have to just, enter my Fabric platform. So I can type app.powerbi.com, or I can just say, yeah, Fabric Microsoft.com. So there are two ways. And I'm going to use my own email address. I'm going to use arbali@exilworld.org, where I'm going to try trial version that Microsoft gives for 60 days, right? So here we can see, okay, let me cancel it for now. Here, I'm using Fabric and Power BI trial. Status is, 58 days left, like this, okay? So let me check my workspaces. I don't have any workspace except this one. So what I'm just going to do, let me, uh, okay, start. Okay, just a minute. So there are some steps that I'm going to do. These steps. So let me find my instructions. Just it will take some of time. Okay. So what I'm just going to do, first of all, I'm going to create say a workspace. So let's create workspace, say new workspace, and this is going to be called Lake House, creating workspace. And for description, I'm going to say lab purpose only. And then I have to be sure that this fabric trial is selected. And then I say apply. And I'm going to just create my, you know, workspace. Now I'm in my newly created workspace, so called Lakehouse Creating WS. Here, the next step is just after creating a workspace is creating a lake house. So to create a lake house, what I'm just going to do while I'm here in my workspace, I say new item. And here, although I'm seeing lake house, but I can type like lake house and it will give me my lake house and say click. And I'm going to enter a name and let me give name, say lake house lab, right? And say create. And my lake house is going to be created. So, and lake house is open. Just pay attention. Here we are going to see Lakehouse Explorer. We have files and we have tables. I have given the necessary information about these tables and files. Just we can say that tables folder contains tables that you can query using SQL semantics. From here, I'll show you a little bit later. And regarding files, this folder contains data files in the one lake storage for lakehouse that aren't associated with managed delta tables. So after repeating the definitions for tables and files, let's upload a file. I'm going to just upload one CSV formatted files from GitHub. So I'm also going to share the link. Actually, this demo has been done based on the lab that can be found on Microsoft Learn related to DP700, you know, just documentation, I mean course. So here I'm saying Control V and say enter, and my data is going to be displayed. By the way, you just can type AKA MS / DP 700 labs. And here you can see all the labs by course. I mean, or by topic, right? Now, this is my, CSV formatted file. So what I say is right click on my mouse and say save as, and let me just click it, select this one. Actually, I have already, saved, but anyway, I'm going to save it once again. And after saving, I'm coming back to my lake house. Here, now the next step is just creating a subfolder under files folder. So I'm clicking on the three dots, ellipses, and say new subfolder. I'm going to call new subfolder like data and say create. And there is nothing here. So my next step is upload files, the file that I downloaded in CSV format to this, subfolder. So I'm selecting this one and three ellipses. Here I have my upload and say upload files. Let me do it once again. Upload files, right? Now, what I can do, I can just click here and let me select the correct folder and select the file and say open and say upload. And it's uploading and it has been done successfully. Now I can just, click on this. Here I see my CSV formatted file. If I can click on this, we can see, our file, right? Now here I would like to talk a little bit about shortcuts. I have also talked in my theoretical part of my today's video about these shortcuts. So, like in many scenarios, the data you need to work within your lakehouse may be stored in some other location. And while there are many ways to ingest data into the one lake storage for your lakehouse, another option is to instead create a shortcut. And shortcuts enable you to include external source data in your analytics solution without the overhead and risk of data inconsistency associated with copying it. So how we can create a shortcut? So from files, just we can say, new shortcut, and we can from here just build a new shortcut that I'm going to skip it. Going back now, we have uploaded our file into data subfolder under files folder. Now it's time to load this data into tables and change its format to convert this data type into the Parquet 1 just to use SQL for analytics endpoint for query purpose. So for this, what I'm just going to do, I'm just going to select this one. Let's select this one. And from these ellipses, I say load to tables, right? So new table. And here, let's pay attention to some stuff. So DBO is automatically selected. And here we can see DBO schema. The new table name is sales. And here we select separator as CSV, for CSV file type. So what we can say load, and it's going to be load into the tables folder. And let's wait for a while it's going to be just loaded, and we'll see it here. And after, we'll refresh this Explorer. So let's wait. Okay, now we successfully create sales table. So what I can say, I can refresh it here. And now I see my sales, right? It's in just table format, right? So if I say file view, here I can see delta, you know, log, and my parquet and my metadata. So this sales CSV has been converted into the parquet file format and includes subfolder named delta log, in which details of transactions applied to the table are logged. So let me change it to table view. Now we can use SQL to query our tables. So for this purpose, I'm going to change it into SQL Analytics endpoint. And yes, here I will see a little bit different window interface where I can see new SQL query and new visual query. So I say new SQL query. This is my first query. Just I'm going to type it, and I have the necessary information about my, sales data set that I uploaded into the system. So I'm going to use the SQL commands like select, okay, and saying that item. So here I'm going to find the sum. My purpose is to group by item by revenue, and revenue is going to be defined multiplying quantity with unit price. So I say just actually select item, comma, and then I'm saying sum. I'm saying sum, opening parentheses. Here, okay, let me do it once again. I'm saying sum and opening parentheses, quantity times by unit price and closing parentheses as revenue. And then I'm saying from sales table, and I say group by, I'm going to use item, and last line code is going to be order by revenue, revenue, revenue in descending order. So, and I'm going to use this one. Okay, let me check once again. So I say select item, sum, quantity times by unit price as revenue from sales, group by item, and order by revenue descending. So here, what I'm just going to do is simply I'm selecting this one and say run. And I'm waiting just the result. And here, let me increase the size. I can see the output. So I have my items with their, revenues. And so this is how we can use T-SQL just to query our data sets. Now I'm going to show how to create a visual query. So for this purpose, from here, I'm selecting a new visual query. And so here I'm following the other way. So I have to find my sales, table from schemas and from DBO schema, from tables. And here I have my, sales table. If I expand it, I can see all the columns. Let me decrease the expanding. So I'm going to drag and drop sales table into this interface. And let me also decrease the size. So here I can see this visual. So to apply visual query from manage column, I'm selecting choose columns. And let me unselect all of them. And I'm going with sales order number and sales order line number and say OK. Now I can see the outputs here. And then I'm going to group by. So from transform, I say group by. And I'm going to group by it by sales order number. And my new column name is going to be, say, line items. And operation is going to be count distinct values. And my column is going to be sales order line number. And then I can say, OK. And this is the result that I'm getting thanks to applying the visual query. So it brings me to the end of today's session. So let me give a brief info about the, uh, you know, um, demo. So briefly saying, you have seen how a lakehouse blends the flexibility of a data lake with the analytical power of a data warehouse, all unified through one lake. Here, in today's session, we explored how to ingest data, transform it, organize it into Delta Lake tables, and query it using both SQL and just using SQL. And you also saw how well-structured lakehouse data becomes the foundation for analytics, semantic models, and actually I have not demonstrated it, but I have shown you how to use SQL, T-SQL codes for querying this data. So I'm just going to my workspace, and here I'm going to select the workspace settings just to delete this lakehouse creating underscore WS workspace. So from workspace settings, I'm going to find remove this workspace option, and thus I will be able to delete this workspace. So from here, I'm saying remove this workspace and say delete. Now, let me go back to my, actually, I hope I will go to the end. Let me shade once again. So, and once again, this brings us to the end of this walkthrough of Lakehouse in Microsoft Fabric. So in our next, session, we are going to talk about how to use Apache Spark for analyzing data, and it's going to be happen in on the same day on Sunday next week. So if you are enjoying this series and want to keep learning with me, make sure to subscribe to my YouTube channel so you don't miss any upcoming Fabric tutorials and demos. Thanks for watching, and I'll see you in the next video. Thank you.